Hello friends, welcome back. Hearty welcome to you. In this session, let us see how to find out the equation of angular bisectors in case of pair of straight lines by considering the symmetric form of a straight line. Let us consider second degree homogeneous equation ax square plus 2hxy plus by square equal to 0, for which we want to find out the equation of angular bisectors. Now, in the last session, we have written it as a combined equation of L1x plus M1y into L2x plus M2y. In this session, we will write it as some value, let us say k, into x sine theta minus y cos theta into x sine phi minus y cos phi, which is a symmetric form. Before moving forward, let's understand what is the meaning of this symmetric form. Just like a recap, we will do what is the advantage of using this form of derivation so that we can finish it quickly. Now we know that any line which is passing through the origin is given by y equal to m1x. Can I say that m1 is nothing but equal to tan theta for an angle theta, then sin theta by cos theta into x, or can I say y cos theta equal to x sin theta, or can I write the equation as x sin theta minus y cos theta equal to 0. Similarly, the other equation will be x sin phi for an angle phi minus y cos phi. So you know, combined equation is where you have to multiply both of them together. So that's how we got this equation in place. We can represent the second degree homogeneous equation by multiplying with a constant k and into two straight lines which are there in the symmetric form as they are passing through the origin. We know that ax square plus 2hxy plus by square always represents a pair of straight line which passes through the origin. Before moving forward, let's try to compare the coefficients and try to get the relation between a and the angles whatever we have, sin theta, sin phi. So let's multiply this, what I will have, and we compare the coefficients of x. X comes from x square term is a, x square term is k into sin theta into sin phi. So can I write down a equal to k into sin theta into sin phi. Similarly, comparing 2h xy terms coefficient is 2h, xy term comes when I take k, take x sin theta, multiply with y cos phi, and also take x sin phi, multiply with y cos theta. So can I go ahead and write it as 2h equal to minus k into sin theta cos phi minus plus cos theta sin phi. So can I write it as sin of theta plus phi, or I'll write down the full step for you. Sin theta cos phi plus cos theta sin phi, that is what is giving us the xy term, which is nothing but equal to minus k into sin of theta plus phi. So these are the two relations. One more we have for b, comparing the y square terms, by square, and y square comes whenever you multiply y term with y term, which is nothing but k into cos theta cos phi. So we can write down that k into cos theta into cos phi. So we need to remember this. So this part we have to remember. So let's put it in a line. We'll not erase that when we go and do this. This is what is our reference which we'll be using. Okay. Now once we are done with that, Now we have written that second degree homogeneous equation is nothing but equal to k into some combined equation we have given. Now we know the equation of angular bisectors is given by, suppose I have combined lines like xy equal to 0, then the angular bisectors is given by x divided by, or let me write it in another way. So if these are the two lines, then we know that angular bisector will have perpendicular distance from this line to any point on angular bisector is same. So can I write down x sine theta? This is the equation of angular bisector we know from the definition. X sine theta minus y cos theta by square root of sine square theta plus cos square theta is equal to plus or minus x sine phi minus y cos phi divided by square root of sine square phi plus cos square phi. Now we know that sine square theta plus cos square theta is 1, so this becomes 1. This also becomes 1. Now we have a situation where we have x equal to plus or minus y. We know the combined equation will be x plus y into x minus y equal to 0, or the combined equation will be x square minus y square equal to 0, where x is given by this and y is given by that. So let's go ahead and do that. Now x square minus y square will be nothing but equal to, let's write down that is x sine theta, x sine theta minus y cos theta whole square minus x sine phi minus y cos phi whole square equal to 0. This is the equation of the angular bisectors. Remember that when I have x equal to plus or minus y, x equal to plus or minus y, then the combined equation will be x plus y into x minus y, or x square minus y square equal to 0. So let us simplify this. We will have x square sine square theta. I'll write down one step where we write down everything. X square sine square theta plus y square cos square theta minus 2xy sine theta cos theta. Can I take this to other side and say equal to x square sine square phi plus y square cos square phi minus 2xy sine phi cos phi. We'll go to the next step. What we will do now, on LHS we will try to keep x square and y square, and RHS will try to keep the xy terms, because that's what we see, only x square, y square and xy terms. So can I write down x square into sine square theta minus sine square phi, that comes from the right hand side, plus y square into cos square theta minus cos square phi, again cos square phi comes from right hand side, equal to 2xy into, from left hand side I get sine theta cos theta, so can I write down sine theta cos theta minus sine phi cos phi. So when we go to the next step, now we know that sine square theta minus sine square phi is nothing but equal to, can we see that sine square theta minus sine square phi is equal to minus of cos square theta minus cos square phi? because I can write sine square theta as 1 minus cos square theta and sine square phi as 1 minus cos square phi. Can I take common in that case? It will become x square minus y square into sine square theta minus sine square phi is equal to xy into, can I take the 2 inside? Then 2 sine theta cos theta will become sine 2 theta. Little bit of trigonometry here we are using, sine of 2 phi. Now let's simplify this. We have x square minus y square as it is. This is sine square a minus sine square b, which can be written as sine of a plus b into sine of a minus b. And here we have sine c minus sine d. From transformation, I can transform this subtraction into product. I can write it as sine c minus sine d equal to 2 cos c plus d by 2, that is theta plus phi, into sine c minus d by 2, that is sine of theta minus phi. Now we can cancel sine of theta minus phi on both sides. What is left out now is x square minus y square into sine of theta plus phi, which is nothing but equal to minus 2h divided by k, is equal to 2xy into cos of theta plus phi, which is nothing but cos theta cos phi minus sin theta sin phi, that is nothing but b minus a. I hope you are okay with that. Cos of theta plus phi is cos theta cos phi minus sin theta sin phi. So I will have b minus a divided by k. Now kk will cancel. We simplify this. In the next step we get, we will have kk will cancel. We will have minus 2h into x square minus y square equal to 2 into xy into b minus a. I can cancel 2 again and multiply with negative. I will get h into x square minus y square equal to a minus b into xy. Now let's do one simple example where we have been given a second degree homogeneous equation. We have to find out the pair of bisectors, equation of the pair of bisector. One simple problem we will do. 6x square plus 11xy plus 3y square equal to 0. We have to find out the equation of pair of bisectors of the angle between the pair of straight lines given by 6x square plus 11xy plus 3y square. Now we know here a equal to 6, 2h equal to 11, and also we know b equal to 3. Our equation is h into x square minus y square, 11 by 2 into x square minus y square is equal to a minus b, that is 6 minus 3 into xy. So the last step will be, we just simplify this. We get 11 into x square minus y square is equal to 2 into 3 is 6xy, or can I write it as 11x square minus 11y square minus 6xy equal to 0. This so we have 6x square plus 11xy plus 3y square equal to 0, a equal to 6, 2h equal to 11, b equal to 3. Substituting in the formula, we get 11x square minus 11y square minus 6xy equal to 0. So I'll catch you in the next session. Till then, keep smiling and sharing. Thanks for your time. Bye for now.